Welcome to Lesson 7 of Cron Mastery, the one where we stop guessing why our jobs failed and start finding out in under a minute. Here's the whole game in one frame. Cron output always lands in one of four places: user mail, the system journal, a log file you control, or the void of dev null. Three of those are findable. One is the trap, and most silent failures live there. So here's the roadmap. 4 skills that compose into one debug workflow. First, we read Cron's own system logs through journalctl, because knowing whether Cron even fired your job is a different question from whether the job worked. Second, we take ownership of output by redirecting stdout and stderr into a log file we control. Third, we use mailto where it actually works and call out where it quietly doesn't. And fourth, we wrap jobs with timestamps and exit codes, so future you isn't reverse engineering what happened at 3 a.m. Before we touch any commands, let's get the mental model straight. Your script writes to stdout and stderr, and from there, Cron asks one question. Does the cron tab line redirect that output with double arrow into a file? If yes, you land in your own log, appended, persistent, findable. If no, you fall into a second question about mailto and whether an MTA is actually installed, and that branch splits 3 ways. User mail if you're lucky, the system journal which only records that the job ran or the void, silently discarded. 3 of these 4 endings are someone else's decision. Only the first one is yours. So let's start with the one log you didn't have to configure, the system journal. Run journalctl ucron with a synths window, and you'll see 3 lines per job. Session opened, the CMD line showing exactly what cron invoked, and session closed. That middle line is gold. It's the verbatim command, redirect and all, so you can confirm cron saw what you think it saw. But notice what's missing. Your script's stdout. The journal proves the job ran. It will not tell you what it printed or whether it exited clean. Which brings us to tool number 2, and honestly, the single habit that separates engineers who debug cron in 60 seconds from those who lose half a day. 20 extra characters on every cron line, double arrow, a log path you control, then 2 and 1. 3 pieces, each doing real work. Double arrow appends instead of truncating, so run 60 gives you 60 entries of history, not just the last one. 2 and 1 folds stderr into stout, so errors and normal output land together in chronological order. And the path? Pick somewhere you own and can actually read, then hand it to logrotate so it doesn't eat the disk 6 months from now. Now, that one-liner gets you 90% of the way there. But once you have more than 2 or 3 jobs, you'll want tool number 3, a wrapper script. The idea is simple. Instead of redirecting raw output, you pipe the command through something that stamps a header, runs it, captures the exit code, measures duration, and writes a footer. Look at the right pane. Every run is bookended by a delimiter with a timestamp, the return code, and the wall time. Now grep becomes a superpower. Find every failure with RC1, every run on a given date, every job that suddenly got slower. Logs stop being a scroll and start being evidence. So, with logging in place, here's the workflow when a job goes silent. 5 steps, in order, and the discipline matters. Each one rules out an entire category of failure. Step 1, did cron even fire? Check the journal for the CMD line at the expected minute. Step 2, did your script actually start? A touch marker on line 1 tells you yes or no. Step 3, and this is where 90% of cases end. Read the log you set up last slide. Step 4. If the error makes no sense, dump cron's environment and diff it against your shell. And step 5. The final test. Reproduce it locally with an empty env. If it breaks the same way, it's environment. If it works, you've found a true cron quirk. Half-day mystery, 60-second investigation. Now, a quick step back. Why does cron behave this way in the first place? Back in 1975, email was the system bus. Every Unix box ran a mail transfer agent, so cron, LPR, sendmail all just handed output to the user's mailbox. It was the cleanest channel available. But fast forward to a default Ubuntu server today. No sendmail, no spool, no mailbox. Mailtow points at nothing, and your output quietly drains into dev null. The default isn't broken, it's orphaned. Which is exactly why explicit redirects matter. They don't depend on what's installed. The log lands on disk where you can rotate it, grep it, ship it. Don't trust defaults you didn't set. So here's your cheat sheet. Print it, tape it next to your monitor. 3 columns mapped to the workflow you'll actually run. Left, where to look, from the system journal down to your own log file. Middle, the redirect patterns, ranked from full capture to full discard. Right? The one-liners that pay for themselves the first time you use them, dumping cron's environment to EMP, touching a marker file to prove the job fired, or running your command under env, I to reproduce cron's stripped-down shell. Memorize the shape. The syntax will follow. Now it's your turn. 3 drills, about half an hour total, all on your own box. First, schedule a trivial job, then hunt it down in journalctl by PID. That's your reconnaissance muscle. Second, build the logging wrapper from slide 6 and prove it captures all 4 pieces: timestamp, error, exit code, duration. Third, the real test. Take a script that works in your shell but you suspect cron will break. Reproduce the failure under env I bin sh, then write the wrapper that fixes it. Do these now while it's cheap. Production is not the place to learn. Before we close out, a quick tour of the 5 mistakes I see most often. And notice, none of these break the cron job itself. They break your ability to find the break, which is the same cost. Single redirect drop stderr. Mailtow assumes an MTA you probably don't have. No log rotate fills the disk. No timestamp or exit code makes the log unreadable. And TMP gets wiped exactly when you need the evidence. Fix each one with the column on the right, and you've eliminated the silent failure modes that turn a 60-second investigation back into a half-day mystery. So that's lesson 7. 4 habits, and you've eliminated the silent failure mode for good. Always append with stderr merged. Query the unit through journalctl. Wrap your jobs for timestamps and exit codes, and lean on the 5-step workflow when something does break. Next up is lesson 8, idempotency and locking, where we tackle the opposite problem. The job that runs twice when it should have run once. Because running twice, as we'll see, is often worse than not running at all. See you in the next deck.